Okay, year 8, we're now going to move into the area of special quadrilaterals, finding the area of these shapes. Let's have a quick review of some things though before we begin. When we realise that, what are we finding when we're finding area? We're finding the space inside a shape. And we measure that area in square units. The area of a rectangle, when we cut that up into squares, will just give us the two sides, adjacent sides, multiplied by each other. Some people like to use length times breadth. I prefer to use base times height. And that's all we need for now. Let's go back to these special quadrilaterals. Because the first thing we need to do is develop formulas. Now, they've given us these four shapes here that we're going to be finding the area of. Now, the parallelogram we've already done, and it's pretty easy. So if we look at a parallelogram, and we can see that this is the height because it's perpendicular. And if you cut this piece off here and put it in over here, what you get, I shouldn't use that, it's too big. What you get is a rectangle where you've got one side, the base, times the perpendicular height. So the area of a parallelogram, which we already knew, is height. The next one we need to use here is a rhombus. Now you can see they've given us a hint here how to find the rhombus. Now a rhombus has some special properties, and the rhombus's special properties is that the diagonals, these two lines, bisect each other at 90 degrees. Bisect just means cut in half. So if I cut this bit out here and this bit out here and fold it over, well, what do I get? I get a rectangle. Now, what do I know about this rectangle? Well, I know that this distance is one diagonal, and this distance is a half of the other diagonal. How do I know that? Because the property of a rhombus is that the diagonals bisect each other. They cut each other in half. So let's call this diagonal X, the smaller one, and the longer diagonal Y, so this one all the way along here, we'll call it Y. Well, that's a half Y, and the area of this rectangle, which is the same as the area of the rhombus, is a half X, Y, where X and Y are the diagonals. It's a pretty good way to do it. There is another way to do it that uses right-angled triangles, but I like that method. Now, the kite does the same thing, and the kite has the same properties. That the diagonal bisect it. Well, no, they don't. This one gets bisected, but they do meet at 90 degrees. But when I cut this shape and put it over, I get a square. And what is it? Well, let's call this diagonal X. So this is a half X times, well, we'll just leave it as a half X because we're going to use the whole rectangle. So half X. And this distance here, well, that's all that diagonal. Well, let's call that diagonal Y. So the whole area if we cut this bit and put it over here, and cut this bit and put it over here, we'd get a big rectangle where this distance is a half x, because it's the diagonal that's been split. This distance is the whole diagonal y, so the area equals a half x y, where x and y are the diagonals. It's most important you label what they are. So what do we got? We've got a parallelogram, where base times height, where it's a perpendicular height. The rhombus and the kite, a half xy, where they're diagonals. Well, let's have a look at a trapezium. Now, I prefer to do this in a different way, and you can use the method that they've got, but just imagine that we find the middle of this point, and we cut this bit out and fold it all the way down here. Well, because this is a middle, this bit and this bit will fold onto each other, and this line will come all the way over to here, and it's on the same gradient, so it goes all the way down to there, and this line goes in there. Now what have I got? Well, let's get rid of some of this stuff so we can see. I've got one big triangle where this distance is the same as this distance. Well, let's label that. Let's call that B. And this distance is A. So this whole distance, remember that's B, is A plus B. And to find the area of a triangle, I need to use the perpendicular height, which is indicated over here. So the area of a triangle is a half the base times the height. So the area, if we cut this trapezium into a triangle, and we can do that with all of them, it's a half the height, or the base times the height. Well, the base is A plus B, and the height. Now, it doesn't matter which order we multiply things. Here we're multiplying this by this by this. So we're just going to write this a bit easier. A half, I'm going to put the H there, and the A plus B. Where, and you need to write this in your notes, A and B are the parallel sides. So they're your four formulas that you're going to need. And here they are. Make sure you've made some notes. You don't need to know where they come from, but you need to know what each things represent. So a parallelogram, base height, rhombus or a kite, half xy, and the trapezium, half times h times a plus b. It's always good to draw a diagram, so I draw a diagram for those notes as well. Now, we have to do questions 2, 3, 5, 6, 7, 8, 9, 10, 11, and 12. So there's a lot of work here, but it's not that hard. So let's go along. 2 is just answering some questions, and we've just done that, so you should be right. Go and have a go at that, and let's see. All right, so you've come back. A perpendicular angle, well, 90 degrees. Look for the little right angle sign. Parallelogram, base times height. The two diagonals in a kite or rhombus are perpendicular to each other. I don't even know what they're asking there. Perpendicular, yep. That's a big word. Just means at 90 degrees. To find the area of a trapezium, you multiply a half by the sum of the two parallel sides. And then multiply by the height. Multiply the size by the perpendicular height. Is that perpendicular again? The two special quadrilaterals that have the same area formula using diagonal lengths, x and y are, that's a kite and a rhombus. Now remember, when you leave school, don't get on the rhombus. Righto. How do I do these ones? And remember, we're going to do 2, 3. We're not doing 4, 5, 6, 7, 8, 9, 10, 11. Now, I'm not going to do all of these. You've just got to select the right formula. So I'm just going to do the first column, see how you go. This is how I think you should set them out. Your teacher might like you to draw the diagram. I don't think that it's needed. But what we're going to do here, first you have to recognise what quadrilateral. So 3A is a parallelogram. So I write area equals base times height. Because I believe it's important that you write the formula and then it becomes ingrained in your memory. So the base, don't worry about whether the base is up the top or down the bottom because they're the same because they're parallel sides. So 10 times 5 equals 50. Please remember to write your units, square metres. The next one, D. Remember, I'm just doing the first column. You need to do the others. That's a rhombus. All right? How can you tell it's a rhombus? All the sides are equal. So the area equals a half x, y. Remember that x and y are the diagonals, so it's a half times 5 times 3. It doesn't matter what order you do it in. And that's 7.5 centimetre squares. Now, G. That's a kite. It has the same area. So it's a half xy. Note that I write the formula every time. A half times, what are the diagonals? 4 times 2, 4 centimetre squares. Notice that I say centimetre squares as opposed to centimetre squared. The last one, J, well, that's a trapezium. Now, this is the one that a lot of people have trouble with. So I suggest very strongly you write it out, half HA plus B. As soon as you see the H, you're looking for the perpendicular height, and that's 8. And A and B are 17 and 7. Let's double check on 17 and 7. 7 plus 17. In this case, I'm going to use my calculator because I don't want to make a mistake. So, a half times 8 times bracket 7 plus 17, 96. And what units is it in? Centimetre squares. The reason I say centimetre squares is because that's the area. There are 96 square centimetres in a trapezium like that. Righto, we're not doing 4. And then these ones are all worded questions. So I'm not going to do them all for you. But you need to have a go at them. So there's the kite, finding the area of that. I might leave that. Question 6. Now this is when there's no diagram, you should draw it. So 6, you go and have a go at it. It's a parallelogram. And parallel just means that all the sides are parallel, and hence, as a property, the opposite sides are equal. It has an area of 26 metres squared. Its base length is 13. What's its height? This is why we did equations. Area equals base times height. 26 equals 13 times h. Okay, well, to get rid of that 13, remember our equations? We have to do the inverse. So we have to divide. So I'm going to divide both sides by 13. And that'll give me 26 divided by 13 is 2. So my height should be 2. And I'm just checking. And it's in metres. So 2 metres equals the height. 7, 8, 9, 10. Do we have to do 10? 10, 11, and 12. I'll do one of 10. And I'm going to do 11 with you, but I want you to have a go at it first. So I'm going to do 10C because it's the hardest. The other ones are pretty easy. 10C. Well, my formula, that's a trapezium. So area equals a half HA plus B. Now, all they're telling you to do is put all the letters in. So what's the height? Well, the height is 2A. A, well, that's 3A, one side, and the other side, 5A. Well, if I remember my algebra, these twos will cancel. So I get A outside of, and 3A and 8A, 5A are like terms, so they add together to give 8A. Now, A times 8A is 8A squared. I'm just going to check, make sure I got the right answer. There we go. The area is 8A squared. Question 11. It's an interesting question. I'd like you to have a go at it. You need to know a bit of geometry to be able to do this question. Now, this shape here is a rhombus, but they didn't give us the diagonals. But you need to understand that a rhombus is a parallelogram. It's the same as a parallelogram. It's just a special parallelogram. It's a parallelogram where all the sides are equal. It's just a special form of the parallelogram. So I can use the parallelogram formula for this. So question 11, a rhombus is a parallelogram with equal sides. So the area equals, I can use the parallelogram formula, base times height. Now, the height there is 8, but because it's a rhombus, I also know that down here is 10. So the base is 10. So it's 10 times 8, which is 80. What units is it in? Centimetre squares. Okay. 12, if you want to. Now 12 is another proof, and the trapezium proof, but we've already done those, so you don't have to worry too much about those. Okay, so you should be right in finding the areas of these special shapes. Make sure you've written some notes about how to find them and write the formulas down every time you do one.